Welcome to Taxonomy Online Mathematics. Today we want to take some questions on BECE 2021. The objectives, we want to see how many we can solve within 10 minutes. So the first one is on which of the set below is an infinite set. Which of the set below is an infinite set? If you know what an infinite set is, so we know a set that the last member is not known. If the last element of a set is not known, it is called infinite. If the last member is known, it is finite set. So right away, set A has number between 2 and 5. The last element is 5. If we take set B, 6 to 15, the last element is also what? Known as 15. If we come to C, 4 to 15, but 3 dots here means that the numbers continues, meaning 4, 6 in that order, it continues to infinity. So we can say that the answer C is the best option for this question, because the D, 3, 6, 5, 15, 15 is the last. So this becomes finite set, finite and finite. So our answer here will be what? C, as infinite set. Good. Here we have to evaluate. This is because we are seeing a base and an exponent, a base and exponent. It means that this is on indices. So we have to try our best to break 84 also to base 2 and 8 also to base 2. Simply put, if you have array of 2, groups of 2, how many will you multiply in order to get 8? So if I have 2 times 2, that is 4. The answer I got is 4. 4 times 2 will give me what? 8. Meaning I'll be multiplying 2 3 times. So this is going to be 2 exponent 3 if I am to break 8 to base 2 and an exponent. Alright, then we are going for 64. So 64, I know 2 times 2, we have 4. Alright, 4 times 2, we have 8. 8 times 2, you have 16. 16 times 2, you have 32. 32 times 2, you have 64. So in counting 1, 2, 3, 4, 5, 6, it means 2 is going to multiply itself 6 times to give us our 64. So this number will be replaced with what? 2 exponent 3. This will be replaced by 2 exponent what? 6. Then we can check what the evaluation will be. So let's go. This is going to be 2 exponent 3 times 2 exponent 6 times our original 2 exponent minus 2 all over 2 exponent what? 5. So if that is out of the way, we can see that they are all having the same base. In indices, we know if I have a exponent m times a exponent n, what do? They are having the same base. So this is going to be a m plus n. If the base are the same in multiplication, we only add the exponent. So right away, this place, I am going to have 2 as the base. Then I'll be adding 3 plus 6 plus minus 2. We are saying the base are the same. So we are only adding the exponent on the base. The base, we pick 1. So all this will be divided by what? 2 exponent what? 5. So in this case, if you add 3 plus 6, I believe you will get 9. Then 9 minus 2 will give us what? 7. So it means the whole of this is going to be 2 exponent 7. So I will rewrite this to become 2 exponent 7 over 2 exponent what? 5. I'm sure you are following the steps. So we have AM divided by AN, or AM divided by AN. If you have this division, what do? The base are the same. So it become A exponent M minus N. If you are dividing bases of the same kind, you will only subtract their exponent. So we are going to have, this is going to be 2 exponent 7 minus what? 5. And I believe that will give us 2 exponent what? 2 as our final answer. 2 exponent 2. We know we can rewrite this as 4. But since this is section A, on the possible answers, the answer will be C. The answer will be, let me check. No, the answer is A on the question paper. The A is 2 exponent 2. So that will be our best option for this question. I believe you get the concept. Good. Then the next one, which is number 3, the R is factors of 15, N is factors of 45. We have to find M intersection N. What will be the values or element in set M that can also be seen in set N? So I'll first of all list the factors. So M is going to be, what are the factors? Meaning, if you are dividing the number 15 by counting numbers, which one will give you exact answer, not remainder? So we know 1 is a factor of every number. So I begin with 1. If you divide 15 by 2, you will get decimal. So we go to 3. That will give us 3. The next number after 3, 4. 4 cannot divide 15, but 5 can. So I have 5. We know 6, 7, 8, 9, 10. They cannot divide 15 without a remainder. So our number will be what? 15. So it means these are the only numbers that can divide 15 without any remainder. Alright. Let's take the N. So obviously 1 will be a factor. We know 45 is an even number, odd number. So 2 cannot divide it. So we go to 3. Obviously 4 cannot go. 5. Then we have 9. What again? 15. What again? 45. Now, when you are listing, maybe you have to check and see that they are pair of numbers. Let's check. Maybe we can have another number which is missing here. 1 times 45 give us 45. 3 times 15 give us what? 45. Then 5 times 9 also is what? 45. So these are the pair. 1, 15, 3, 5 as our pair. So if I'm looking for M intersection N, I am asking myself, what are the elements in set M that I can see also in set N? So I'm going to cross them out. This and this is common. I'll cross 3 and 3 as common. 5 and 5 as common. 15 and 15 as what? Common. So these are the numbers that are common to the two sets. So on the possible answer, we are going to have question number 3 to be 1, 3, 5, 15. So that will be possible answer B, option B on the question paper. That will have given us our answer. So easy, right? Alright. Then find the gradient connecting the set A and B. So fast forward, we know to find gradient of two lines, it is the change on the y-axis over the change on the x-axis. You can decide to use y1 minus y2, x1 minus x2. It's still a change, but the change will be in order. You can't start with y2, y1, then you begin with x1, x2. No, that will not be in order. So since A comes first, A become my first x, second here y will still be the first y, then x2, y2. So if this is y2, I'll be having 10 minus 9 all over 6 minus what? 4. As in terms of x2, y1, we have y2 to be 10, y1 to be 9, x2 6, x1 4. Then we can perform our subtraction, and that will give me 1 out of what? 4. No, 1 out of 2. 6 minus 4 is 2. So the answer is going to be half as our gradient. And that on the question paper will give us option B. The option B will have been our best option. Good. Let's take another. The highest common factor of this, we have to find the highest common factor of 48 and 96. So we are going to list the prime product. So let's say I want to draw a factor tree. So 48, then I am looking for two legs that multiply to give me 48. I can say that will be 6 times what? 8. It could also be 2 times 24 or 12 times 3, any factor you want to. Now in the factor tree, we are looking for the legs that are having prime numbers. So I have to break down this and this to have prime factors. So the factors of 6 will be 2 and what? 3. And I can see that 2 and 3 are prime numbers. So this becomes the final leg of the factor tree. Then here is going to be 2 and what? 4. 2 is a prime number, so I end there. 4 is not a prime number, so I begin on 4 again to find another factor. That will also give me 2 times what? 2. So we are picking the leg, the final leg with the prime numbers. So 2, 2, 2, 2. How many of the 2? So 2 exponent 4 times what? 3 will give me my 48. So if I am to list the prime product, if 48 is going to be 2 times 2 times 2 times what? 3. That will be 4, the 48. Alright, let's take our 96. So 96, if I want to take, I can take what? 2 and 48. You know, 2 can go here 48 times. I can also take what? 3 as what? 32. So let's say I have 3 and I have 32. What are the other numbers that are factors that we can break this into? I can break this into a factor of, let's say, if I have 3 and no, let me use 4. 4 and what? 8. 4, 8 give me 32. This will have a leg of 2 times 2. Whilst this will have a leg of 2 times 4. And 4 will also have a leg of what? 2 times 2. So 2, 2, 2, 2, 2. Then we have 3. 1, 2, 3, 4, 5. So in the case of 96, I'll be having 2 times 2 times 3. So I'm looking for what? The highest common factor. So I'll begin with what? The highest common factor. I am looking for numbers that are common to the two numbers, or factors that are common. So in this case, or let's say I cancel this, so 2 is common. If I cancel this times 2, if I want to cancel this, I have to cancel the 3 behind. Don't forget, this 2 is not having a counterpart, so I leave that one behind. It is only going to be common if you have a counterpart in the other number. So right from here, 1, 2, 3, 4. So it will be 4. And 2 exponent 4 will give us what? 16. Then 16 times 3. If I have 16 times 3, this will be 18. Then I have 1 times this, so I have 48. Meaning 48 is the highest common factor for 48 and 96, not 24. So with this, we have 1, 2, 3, 4. So 1, 2, 3, 4. So that will be 2 exponent 4 times what? 3. Alright. So the possible answer will have been B. Then the next one, express 2700 as a product of prime factors. Just like we did here. We want this to be in the same order. Good. So we can follow this as in 2700. I can do that without drawing a factor tree. That would be that if I have this number will be 100 times what? 27. 100 times what? 27. So I can take 27. Going to be 27 times what? 100. But I know that 27 is not a prime number. That I'm looking for, the least prime number I'm looking for. 2, 3, 4, 2, 3, 5, 7, those numbers. So I'm going to break this one down. As in the case of 27, I have 3 times what? 9. 3 times 3 gives me 9. So this is going to be 3 times 3 times 3. Then I will take my 100. If you take 100, you know the length will be 10 times 10. And 10 times 10 gives me 100. So I break this further to be 2, 5, 2, what? 5. Meaning this is going to be 2 times 2, 5 times what? 5. But we want to arrange in ascending order. So if in ascending order, I am going to have 2 exponent 2, 3 exponent 3, 5 exponent 2. Meaning 5 is multiplying 2 times. I have 2 multiplying 2 times and 3 multiplying what? 3 times. And in the possible answers, that would have given us A. No, that will not give us A. That will still be B. That will still be B. The A have exponent of 3. 2 exponent 2, 3 exponent 3, 5 exponent 3 in possible answer A. But B has exponent of 2. So that will be our best option. I believe you have followed the procedure. Good. We are on number 6, but we have 16 to 17 minutes. I wanted this to be in 10 minutes, but because of too much explanation, the next episode we take the next set of questions, either 5, 6, or 10, depending on the explanations I'll give or the weight of the question. If you have not subscribed, please subscribe to the channel. If you like this video, as in you appreciate it, find it useful, then give a thumbs up by liking the video, leave your comment, and share with your colleagues. Share with somebody who is in GSS 3, going to write BECE, or somebody in Form 2 who is preparing to go to Form 3. Share with them, let them have a feel of how the questions will be set. See you as we take the next set of questions.